I thank you all for watching my videos all these years. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of June 2023. This question is from the section Complex Analysis and it is related to the concepts of entire functions. This question is from the part C, which is a multiple select question. There can be more than one answer, and this question carries 4.75 marks, and its question ID is 704082, and this question is suitable for all these examinations. Right. The given question is, let f of z be an entire function on the whole of the complex plane C. Which of the following statements are true? We are given four options. Option 1, f of z bar is an entire function. Option 2, the conjugate of f of z is an entire function. Option 3, the conjugate of f of z bar is an entire function. Option 4, the conjugate of f of z plus f of z bar is an entire function. Right. We will now discuss the solution of this problem in detail. We are given an entire function f of z. Let f of z is equal to u of x comma y plus iv of x comma y. That is, u and v are the real and imaginary parts of this entire function f of z. F of z is an entire function means f of z is analytic on the whole of the complex plane. That means it is analytic at every point of C. That means the first order partial derivatives of u and v, they exist and they are continuous in R square and satisfy Cauchy-Riemann equations. That is, ux is equal to vy and uy is equal to minus vx at every point of R square. Right. So we move on to the next slide for the discussion of the options one after the other. Now, in options 1, 2 and 4, we take the example f of z is equal to z, and we say that the options 1, 2, 4 are not true. When f of z is equal to z, it is an entire function. Option 1, f of z bar is an entire function. That is, now f of z bar, f of z is z, f of z bar is z bar. And it is well known that z bar is nowhere analytic. You can see here, let g of z is equal to z bar is equal to x minus iy. The u, the real part of gz, is x. V, the imaginary part of gz, is minus y. Ux is 1, uy is 0 because u is free from y. Vx is 0, vy is minus 1. And ux is not equal to vy because ux is 1 and vy is minus 1. They are not equal at any point. Therefore, the Cauchy-Riemann equations are not satisfied at any point. Therefore, g of z is nowhere differentiable. When it is nowhere differentiable, it is nowhere analytic. So, g of z is equal to z bar is nowhere analytic. When it is nowhere analytic, it is not an entire function. F of z bar is not an entire function. Option 1 is not true. Thus, option 2, the conjugate of f of z is an entire function. Again, we take the same function f of z is equal to z. So, the conjugate of f of z is z bar, which we have already seen, is nowhere analytic. Therefore, it is not an entire function. Therefore, option 2 is not true. We go to the option 4. The conjugate of f of z plus f of z bar is an entire function. The same example we take, f of z is equal to z, then it will be equal to z bar plus z bar, that is equal to 2 times z bar, which is again nowhere analytic. Therefore, it is not an entire function. Option 4 is not true. Thus, we have proved option 1, option 2, option 4 are not true. Therefore, the remaining option, option 3, must be true. The remaining option 3 says the conjugate of f of z bar is an entire function. So, this is true by elimination. So, by elimination, the answer to this question is option 3. So, the question is over, but our students will ask a proof for option 3. That we will do it in the next slide. Right. We have the option 3. The conjugate of f of z bar is an entire function. And what we have is f of z is u plus iv is an entire function. And the first order partial derivatives are continuous and Cauchy-Riemann equations are satisfied at every point of R square. Agreed. Now, f of z bar is f of x minus iy is equal to u of x comma minus y plus iv of x comma minus y. Agreed. Take the conjugate of f of z bar. So that will be the conjugate of u of x comma minus y plus iv of x comma minus y, and that will be equal to u of x comma minus y minus iv of x comma minus y. Call it as capital U plus iv. So where capital U is small u at x comma minus y and capital V is minus small v at x comma minus y. Keep this in mind. Agreed. To show that the conjugate of f of z bar, we have to show that capital U and capital V possess continuous first order partial derivatives and satisfy Cauchy-Riemann equations on the whole of R square. Right. So, first order partial derivative of capital U with respect to x is equal to, you go to capital U, differentiate partially with respect to x, small u x at x comma minus y. Capital U partial derivative with respect to y is u y, differentiate partially with respect to y at x comma minus y at x, and minus y with respect to y is minus 1. So, you will get a minus. Vx at x comma y, Vx capital V is minus V at x comma minus y. So, partial derivative with respect to x is minus Vx at x comma minus y. This minus is because in the Cauchy-Riemann equations itself that minus was there. Vy at x comma minus y is, there is already a minus, minus V at x comma minus y with respect to y is Vy at x comma minus y with respect to y is minus 1. So, minus 1 plus minus 1, minus of minus 1 is plus 1, Vy of at x comma minus y. Let us see, this small ux, uy, vvx, vy are continuous in R square because they are there in the entire function itself. Therefore, this will imply ux, uy, vx, vy, small ux, small vy, small vx, small vy at x comma minus y. They are also continuous in R square because they are continuous in R square. Right. What about Cauchy-Riemann equations? Ux, uy, vx, vy are continuous in R square. Capital Ux, capital Vy, capital Vx, capital Vy are continuous in R square. What about Cauchy-Riemann equations? Ux, capital Ux is small ux at x comma minus y. But small ux at x comma minus y is Vy, ux is equal to Vy at the same point x comma minus y by Cauchy-Riemann equations for f of z, and vy, small vy at x comma minus y is here, is equal to capital Vy at x comma y, right? Uy at x comma y, uy at x comma y is minus uy at x comma minus y. The Cauchy-Riemann equations for f of z, uy is minus vx, there is already a minus, so it will be vx, small vx at x comma minus y. But what is vx at x comma minus y? So capital Vx at x comma y is equal to minus Vx at x comma minus y. Therefore, small v at x comma minus y with respect to x is minus capital Vx, So thus ux is equal to vy, uy is equal to minus vx. Those are the Cauchy-Riemann equations are satisfied at every point of R square. Thus your the conjugate of f of z bar is an entire function. Thus, option 3 is true. The answer to this question is option 3. That is the detailed discussion of the solution of this problem from the section complex analysis, which is related to the concepts of entire functions. And this question definitely very easy. Normally people will do by elimination process and they conclude option 3 is true. But the proof of the option 3 is given here. I am sure that you have understood the solution of this problem. I thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We shall meet once again for a further discussion on other topics. We will meet once again in another episode of learning. I wish you all the best. Thank you.